Hello, welcome to another episode of Ksa Talk Show. So today we are going to explore the data structure of stacks versus list. So basically in Python, in Ruby, in JavaScript, you all have a list or array data structure. And there is also a data structure called stack. So we are going to try to implement a efficient stack. We're gonna do that in Python, in JavaScript, in Wolfram language, and we are going to time it to compare with millions of items and push and pop, and let's see whether our customized stack data structure is going to be more efficient or faster than the building using the built-in smart array or smart list. So Python, JavaScript, Wolfram language. We're gonna explore. Okay. So if you don't know, if you are new to programming, I'm going to explain everything. Okay, and I'm also going to demonstrate the Lisp programming languages list, which is basically made of const cells. We'll get to that. Okay. So basically, essentially, we are going to implement Lisp's const cells in Python, JavaScript, Wolfram Lam, and time it. Okay. So why do you need to do that? So let's begin. Okay. If you comments, post comments and questions, I love to see it. Okay, so Wolfram language, Python, JavaScript, and the keyboard I'm using, this is Xpose. I talked about many times in lots of my videos. You can see reviews here. So Xpose is one I recommend. I also recommend Kinesis. Kinesis 360 is also good. Gloves 80 is also good, but it's not out yet. SRail Neo 76 is also good, but too expensive, 500 something. Same with the Kinesis 360. Apple Maker I just discovered is pretty good, or you can buy any of the others. Okay. So anyway, so Xpose is what I'm using, and over there is over on top and on the side you cannot see, but over there it's ultimate hacking keyboard. I have reviews on my website. Okay, it's hot. Let me check off. So yeah, stacks. We're gonna implement stacks. Yeah. Okay, let's begin then. Today's talk show. So why do we need to do that? Okay, first of all, let me show you Wikipedia articles. So you can read it later. Okay, so there is a stack data structure, not that, not simple Wikipedia. Okay, I don't want the simple English. By the way, simple English is a good thing. But 53 languages, yeah. Stack, okay. Data, abstract data type, okay. There it is. So a stack is a data type. You can think of it as a pile of plates. So when you put some data such as numbers or string, you push it to so it's like plates or stack of books. You put it and you put another one on top, put another one, you can pile them up. So it's like a list. Okay, it's like a list of things or sequence of things. Okay, a pile of stack of plates or books. Then if you want to get there are two operations are allowed for a stack. That is, get the first item. So you can take out the first item, remove it, and get that value. Okay, so you can just like you removing books of a stack of books, and there are two operations: push, add another thing to the stack, or pop, which is take out a thing from the stack. Okay, two operations. So it's a list, but only two operations. You can add to the front or take from the front. That's what stack is. Now let me explain. So that's a stack abstract data type. Okay. So there are Now there is another, the most fundamental data structure in every programming language, okay? That's called array, okay? Now, the jargons array, list, stack, they mean different things in different languages. So depending on the language, for example, so let me say again, array, vector, list, tuple, these four things, depending on the language, they may mean different things, but there are two standard jargon. Let me show you, okay? So in Python, so first of all, let's think of a list. It doesn't matter it's a stack or what. Let's not care about specific properties. Let's say we just want an ordered sequence of things. What is it called in different languages? So in Python, it's called, I believe they call it list, okay? So in Python, it's called a list. You just do it like that, okay? Let's put the link into my website. So in Python, it's called a list. Now let's go to in Wolfram language, it's also called a list, okay? Okay, so Wolfram language, and you write it like that or like that, two different ways, okay? So let me explain what are we doing. List, vector, array, let's say array, let's order them this way, array, vector, tuple, list. Actually, let's put list here because it's the most common jargon. So all these jargons essentially means almost the same thing. Exactly what they mean depends on the language, okay? So don't get confused. Sometimes, if you are programming in Python versus you talking to people programming in Wolfram language or Haskell or JavaScript, when you say a list, they might think of list as something else different from you. So first of all, remember that these jargons have different meanings in different languages, okay? So we look at Python, so Wolfram Python. So first of all, if you want an ordered sequence of things, typically they all mean just an ordered sequence of values, okay? But they differ in some. So what's the difference? They differ in some algorithmic properties. For example, can you how fast is it to access any random item? Let's say nth item. Okay, that's the question. So if you have a list, let's say 10 things, let's say 1,000,000 things. Now, if you want to get the 10,000th item, is it instantaneous? I mean, does it make a difference? Does it make a difference if you get the first item or some millionth item? So that is the question. You see, all these things are just list ordered sequence of things. So why is it different? Well, because depending on computer how it's implemented, the exact machine, may it be Abacus or a Turing machine, a physical Turing machine, or whatever, or CPU, today's modern electronic computer, or is it DNA computer or quantum computer? So but a sequence of ordered things is a fundamental, natural, mathematical concept. You cannot escape it. So there is a concept of ordered sequence of things, okay? In English, we just call a list, okay? Ordered sequence of things. But when you actually want to program it, requires a machine hardware and and algorithm, and you have to write down the algorithm in a programming language that specify the instruction what to do with the machine. When you actually do that, then to create something like an ordered sequence of things, then you have questions like how fast is it to access nth item. There are different ways to do it. So you have that question, and you also have a question of can you add items to the list? Okay, can you add items is it slow or fast? Okay, so you have that question. So one thing I want to tell you, remember that these are not fundamental concepts in mathematics. So this just depends on what machine you're working on, what programming language you're working on. It depends on the machine, the CPU, the instruction set, the programming language, okay? So that's why you have these questions. How fast is it to access nth item? And can you add items to the list? Or can you delete items in the list? Okay? So these two are the most fundamental question to this bunch of jargons. Very confusing because if you are a beginner, you may not know. So it all depends on the machine, on the implementation, and on the programming language. And each programming language, they may use different jargons. But in essence, typically, you just have a ordered sequence of things, and you have these properties about them. How fast is it to access nth item? And can you add items to the list? Is it slow? Or can you delete item to the list? Okay, that's the fundamental properties, algorithmic properties. These properties came from the implementation and the programming language, and also the machine. Okay. Now that's a situation. Okay, so let me write it down so people can easily understand. For ordered sequence of things. Okay, that's one thing. Now, this is very confusing topic. Okay, very confusing topic. That's why we need to be very careful. You want to memorize exactly what's going on here. Okay, so first of all, so you have different jargons for ordered sequence of things. Okay, then you have what do they mean? Okay. Okay, so let's put that different jargons for ordered things. Ordered sequence of things is a natural math concept you cannot escape. Okay, that's the important point. Ordered sequence of things. That's a universal concept. Okay. Now, implementation detail. Okay. Implementation detail. Okay. And algorithmic. Okay, I don't have a shortcut. Properties. Okay. Implementation detail and algorithmic properties. Okay. So they differ in some algorithmic properties, and the most fundamental are the most fundamental are how fast is it to access any nth item. Or in other words, does it take longer time to access items far from the first? Okay, that's a question. Okay, so how fast is it to access any nth item? And the other question is, can you add items to the list? And is it slow or fast? That's the two most fundamental differences. Okay, and let's add another topic. Why does these differences exist? Okay, because it depends on the machine, aka computer, and the design of the machine depends on the design of the machine, and depends on the implementation of the algorithm or the programming language implementation of its list vector array data structure. Okay, that's so far, that's what we have covered. Okay, now let's put this here. That's so far what we have covered, and let's remove this. Okay, now I'm explaining the preliminaries. Why do we need to do this? Why can't we, we are explaining the preliminaries. So now next we want to, so this is why we need to try to implement a efficient stack. Okay, so and let's add what is a stack. What's a stack? Okay, it's like a stack of books. You have two operations, push and pop. Push is add an item to the top. Pop is remove an item on the top. Okay, that's a stack data structure. So a stack is just like, again, it's like an ordered sequence of things. But in this case, you cannot, get the nth item. You only allow two operations: take item from the beginning and drop it, or add an item in the beginning. Okay. Now let me explain. Now, so we talked about how the, so exactly the algorithmic properties depends on the machine and depends on the programming, depends on the programming language, how it implements it. Okay, for example, in Lisp, for example, Emacs Lisp. For example, I'm showing you some Emacs Lisp code. For example, in Lisp languages, including Common Lisp, Emacs Lisp, Scheme Lisp, Racket Lisp, their fundamental data structure is called a list. And the way this list sequence of things, ordered things, the way this list in Lisp is implemented is by a method called linked list. Okay, and with that implementation, how fast is it to access nth item? Very slow. Okay, the further away from one, the slower it gets. Okay, that's Lisp's list. And can you add items to the list? Yes, but only at the beginning. Okay, it's very fast, constant time. You can add the item to the beginning, or you can delete the item from the beginning. However, if you want to add an item somewhere in the middle, it takes a lot of time. You essentially have to do it takes more time. It's not constant. The further away from the beginning, the longer it takes. So that's the algorithmic property of the Lisp's list. Okay, so let me show. Let's write it down. Property of Lisp's list. Okay, including common Lisp, Emac Lisp, Scheme Lisp, Racket Lisp, but not Clojure Lisp. Okay. It is constant time and fast to it is slow to access nth item. The further n is from 1, the longer time it takes. Okay, but it is constant time and fast to add an item to the beginning of the list or delete that item. Okay, very fast. So you can always add or delete items in the front very fast. But if you want to delete or add nth at the nth item, it's proportionally slower. Okay, so that's the algorithmic properties of Lisp's list. Okay, so the Lisp's list. Now let me show another point. Lisp's list is traditionally called linked list in computer so far that's the things we covered. So Lisp's list is called linked list in computer science, so kind of confusing. Hello guys. So let's start to implement. I already took 30 minutes. Oh shit. So just to explain this prelude took 30 minutes. So now let's begin to code. So you have some general idea why, what's a array, list, vector, tuple. I mean, they are all just ordered sequence of things. Why your programming language has all these? Okay, now you know. And so mathematically, they are just ordered sequence of things. So basically, the whole thing we are doing today is not a mathematical concept. This topic took me 20 years to understand. So, I began programming in 1993. Wolfram language, Perl, Python, then PHP, then JavaScript, and also Clojure. So I did, a lot. It took me, and Lisp, I did some Scheme Lisp too, and Emac Lisp, of course. I've been coding Emac Lisp for 15 years. So, but this concept of, why why are there these things? Why are they different? Why can't they just all be fast? Why can't you just, create an array that's, you can grow, you can delete elements at anywhere, you can add element anywhere, and why can't it be fast? Why not? So all this took me 20 years to actually finally understand. And I would say even the C++, these hardcore programmers, they don't know why array is fast. I mean, why array is constant access time. Okay, let me explain a few more things. So this is the topic we are going to do. We are about to begin coding, but let me explain few more things. Okay. So we explain linked list. Okay, linked list is very important, critical concept. Okay, let's write it down. Okay, critical concept, linked list. Okay, so first of all, okay, hold on a second. Actually, before we can actually fully explain what is linked list, we need to explain what is array first. Okay, so let's explain what is array. Critical concept, array, Akka, C's array, C or Java array. So that's a critical concept. Okay, let me explain that. Critical concept, C or Java's array, and okay. Okay, so this, in the beginning, there is this thing called array. Now let me explain exactly what it is. Again, it's just a ordered sequence of things. Mathematically, it's an ordered sequence of things. But this jargon, array, by convention, has a specific algorithmic property. It is, okay, so what is the property of array? The implementation. So fast, constant access time to any item, but the array cannot grow or shrink. That is, cannot add or delete elements. If you do, you basically have to create a new array. Okay. So first of all, critical concept, and this is the most of them all, the most important data structure in all languages. You have this array. Oh yeah, I wanted to say fixed length array. Okay, so it has these properties: very fast, constant. If you want the millionth item, you'll get that value just as fast if you want to get the first value. Okay, constant time, magical. It's almost like magic. It's almost like quantum computing, parallel. This is a very weird concept. This is very weird. Took me 15-20 years to understand. Why is it access the millionth items is as fast as accessing the first item? Why is that? Because imagine a hardware abacus. If you are using abacus, you have to move your hand, to the millionth item. It all depends on where your hand is. So you have to move. The further away from your current hand position takes longer. But that's not the case. Or imagine a tuning machine. Tuning machine is a kind of a abstract machine. You have a tape. You need to move the tape. If you implement array on a tuning machine, how is it possible you have this constant time access? Okay, this puzzle took me like 20 or 30 years to understand, and eventually I did about 7 years ago, about 10 years ago, and that is. Let me explain. Okay, so and that is. Hello, George. So we are going to implement stack, but not yet. I'm just explaining the background. Not Xali.org. Okay. So you just go to xali.info. There's an article I want to show you. So let's say constant. Okay. Why is array access constant time? Now the reason this data structure array, C's array or Java's array, again, depending on the language, each language uses different terms, but in C and Java, their meaning of array is more universal. Okay. So when people say array, typically it means like C programming language is array or Java programming language is array. Okay, so when you have an array implementation of the ordered sequence of things, then you have this property, constant access time. Doesn't matter millionth item or first item, it's the same speed to get it and very fast. So it's magical. Why does it happen? Even so if you can look at Wikipedia, it has 10 pages, 10,000 words, but no explanation why. Except this one single line. Okay, one single line, brush it away, hand waving. Okay, they effectively exploit the addressing logic of computers. What does that mean? What do you mean effectively exploit the addressing logic of computers? So people do not, you ask programmers, even or basically essentially all textbooks, you go to Amazon, you buy the classic textbooks on algorithms. None of them, as far as I know, none of them explains it. Why is array access constant time? They don't explain it. They just say it's constant, okay? Then they tell you how to implement linked list and others. But they just assume, they will just begin with array, the data structure is just constant time. No explanation. And in fact, from my experience talking to, the low-level programmers, I'm not a low-level programmer, but I talk to C, C++, Java. They don't know neither. They cannot explain. They'll just say array access is constant. Okay, if you don't know, you are an idiot. That they don't know. They don't know themselves neither. But somebody knows, of course. There's always someone knows the answer. Those are the people who actually designed and implemented the memory chips or CPU chips. They design it. They design the electronics, how it works. Those people do know, okay? Those people actually understand. Because even if you are a C programmer, you wouldn't know. Even if you are an assembly programmer, you wouldn't know. Why? Because the answer has to do with the design of the memory chips, how it's accessed. Okay, essentially it's just parallel in nature. So this is a very important thing, answer. Okay, and I learned it from this guy, a famous Chinese blogger, programmer and computer scientist, Ying Wang. So why is array indexing faster than binary search? That's the way he put it. But basically, array indexing is constant time and fast. Doesn't matter which element, millionth or the first element you access, because how the electronics and memory chips are designed. It's essentially the answer is just parallel. Okay, that's why. Nothing. Now this has nothing to do with mathematics. Okay, this is not a natural mathematical phenomenon. It's not a math theory, nothing like that. It just happens. It's engineering, it's history. Okay, it's the reason array access is constant time because we are using this particular design of memory chips and the electronics, electricity running around and transistors, and they are lined in a parallel way. That's why array access is constant time. Okay, that is why. So this is very fundamental. This is the most fundamental thing. Okay, this is the most critical and fundamental property. Because of this, then we begin to talk why implementation details, algorithmic properties. You have array, vector, tuple, stack. All those depends on this. Array access is constant time. Okay, they all begin with this. Then from this array data structure, then you create other things such as linked list, stack, circular list, or even hash table. It all depends on this property. Array access is constant time. Okay, so this is very fundamental, and what has been a big puzzle for me, and none of the programmers I've seen able to explain to me until 10 years ago. I found this guy's article. Not in textbooks, not in Wikipedia, basically not anywhere. I wonder if Knuth in his other programming, if he actually discussed that. So if you read Knuth, other programming, if you know, tell us. Okay, maybe Knuth explained it. I really want to see. I really like to see. Okay, so we have this. We touched on why array access is constant time. So now, this is critical concept array. Okay, so in Java, in C, you have the array concept, fast constant access. However, you cannot grow or shrink. That's another puzzling question. So because mathematically, if you are the genius from Mars or from outer space, you are the greatest mathematician, your math abilities is beyond all humanity. So you want an ordered sequence of things, but why is it you cannot grow or shrink? What's going on? How is it possible you cannot add to an ordered sequence of things? Well, because we're talking about computers. You have a specific machine, you have a specific implementation, and it so happens, again, because of the electronics, not necessarily other machines like quantum computing, or based on other DNA computing, or based on abacus, not necessarily other, but specifically the modern times are electronic computers. Specifically because of these, you cannot add elements to array. Okay, you can, but basically you have to do is just delete the whole thing, make a copy, and create a new array with a new element in front or wherever. That is why. Again, because of the hardware electronic design of the memory and CPU. Okay. So okay, that is why. Let's write it down. Okay, so we want to write down this. Copy, close, back to Emacs. Why is array access constant time, and why cannot we add or delete element in it in constant time? Okay. In other words, why can't we do it fast? You cannot. critical concept array, okay? And why is array access constant time? And why cannot we add or delete element in it in constant time? Because the CPU, okay? I mean, because the memory chip, the way memory chips is designed in electronics, okay? Electronic computers of today, maybe not tomorrow, maybe, current technology, okay? So one thing I want to emphasize again, all this is just happenstance. It's not mathematical property. These, constant time and these are not part of theoretical computer science, okay? Many of the C programmers, they don't know, okay? These programmers, they don't know. The things we are doing today is not part of theoretical computer science, okay? They are just part of computer engineering, okay? All these, complexities is not natural, okay? It doesn't come from nature. It just came from the way we happen to design electronic computers. Okay. Now, so now we start to so we have the array of C and Java, okay, which is fixed length. You cannot add to it, but access is fast. Doesn't matter which item. Okay. From there, then we developed other data structure with different properties for a sequence of ordered things. And one of the most prominent is called linked list. Okay, sometimes just called list. But again, different languages use different terms. So how do you do a linked list? So first of all, what is a property of a linked list? Linked list is such that you can add or delete items in the front very fast, constant time, but you cannot access arbitrary items fast, okay? And the way it's done is by, okay, we already took 50 minutes. Shit, we are now going to code. Okay, so, but this is important. So let me just show you Lisp code, okay? So list, okay, let's start to show code. Let's start to code, okay? So start Emac Lisp. Okay, let's code. So I'm going to code a list. I'm going to show you how linked list is designed. Okay, but let's write down the properties first. I mean, so what is linked is what is a linked list? Okay, linked list, or in short, list is a connect is a nested tail nested sequence of two items. Okay, that's what it is. Okay, and for example, let me write an example. Suppose we want a list of items A, B, C, D, okay? In linked list, it looks like this, okay? So A, B, C, D. Okay, so you can see it's just you have a pair of things, then you just nest it. So if you want a list of A, B, C, D, or ordered sequence of things, the way you implement, if you want to implement it as a linked list, then what you do is you start with a pair, and so the first item of the pair represents the item in your list, and then the second part of the pair is again a pair, and the first part of that is the item of the list, and the second part is again a pair. So all the way until you reach the last item D, A, B, C, D, D, then the second part is just nil or some other thing like 0 or special, special item indicate that's it. Okay, so you have this nested structure to represent a list. And this is how Lisp programming language implement their list. Okay, so let's show some Emacs example, Emacs Lisp. Then let's start to so for example, let's say list. Okay. How we want to do that? A, B, C, D. I hope I can do this correctly. So that's a list. It is equivalent to. Now in Lisp, this pair you are seeing, it's called const pair, and it's written like that. Wait. Let's not use A, B, C, D. Let's use 1, 2, 3, 4 because we avoid the symbol problem. 1, 2, 3, 4. Okay, so let's 1, 2, 3, 4. Okay, so now let's go back. So we have a list there, and this list is actually, so in Lisp, remember ordered sequence of things, Lisp call it list, and it is actually implemented as a linked list, and it looks like this. Okay, let me show you. Const 2, const 3, const 4, and nil. Okay, that's a linked list. Okay, how do you know? Well, we can show they are equivalent. So let's try. I'm not sure this will work, but I think so. So we're gonna evaluate this, test equality. Evaluate it nil. Okay, so wait. You see, true. You see the output is true. Let's start again. You see, true. This shows how Lisp list is implemented as nested pairs. Okay. Okay, so there it is, linked list. This is called linked list in computer science. Okay, so let's go to Wikipedia so you can see, you can read about it later. Okay, linked list. You can see that, that pairs, you just nesting pairs. Okay. Now this linked list, again, the property of this way of doing an ordered sequence of things is that it's very fast to remove the front items or add items to the front. However, it's very slow if you want to get the 10,000th item. The further away, the slower it is, because it has to go through all the, kind of nesting links. Okay, that's a property. Okay, and let's write down the property. Algorithmic property of linked list. Did we already write it down somewhere? There it is. We already did. Algorithmic property of list. Okay. Okay, so and this linked list is exactly also the most efficient data structure for a stack. Because remember, a stack is a data ordered sequence such that you can always add or remove items in the front. Just these two operations, push and pop, add or remove items in the front. So it's very fast for linked list. Okay. Let's add a header. Okay, and that is exactly what we are going to do, or we are about to do. We are going to implement a linked list in Python, in JavaScript, and in Wolfram language. Okay, and we want to compare the speed. Hold on a second. There's one more thing. I want to explain why we need to do that. I mean, so let's explain Python's list. Okay. Python and Ruby and JavaScript. Python, Ruby, JavaScript, their list or called array is a smart array for lack of standard term. Okay. So in Python, or if you program in Ruby, or actually I don't, So in Python, in Ruby, in JavaScript, if you are familiar with them, they have a data structure called list. Well, in Python, it's called list. And in Ruby, George, what is Ruby's list or array data structure? George is an expert of Ruby and JavaScript, a professional programmer. So in Ruby, I don't know Ruby well, but I just learned it. Do they call Ruby? I mean, what is the official jargon for Ruby's list? Do they call it array or list? We can find that by searching it quickly. Okay, so in Ruby, it's called array, I guess. Yeah, Ruby. So Ruby calls it array. In JavaScript, it's also called array. Okay. So you have this. So let me explain this one. So mathematically, you have the concept of ordered sequence of things. But however, when you have a machine, a physical machine, and a programming language, which is a written instruction on how to manipulate machine. So when you work on an actual machine, you need to, you need the programming language you need actual instructions, how you manipulate a machine. You need to design you need to implement the data structure. You need to make this abstract concept of ordered sequence of things into some actual instructions. So when you do that, you have issues. You have issues of implementation detail and algorithmic properties. What are the issues? That is, the issues, is it fast to access any random element? Or can you add or delete items in the element? Is it gonna be slow? So you have these questions comes up. Okay. Why there are these issues? Because you are actually working with a machine. Machine programming language turns your code into actual instructions. Do this, move this here. That's why you have these things, and these things came from, again, all based on array. Array is because it so happens of the digital electronics. So array, you have the array implementation, which is fixed length but fast random access time, okay, array. So from array, then we started to do, we can have linked list. Now, so the question now is what about Python, Ruby, JavaScript, what do they do? Okay, now we know in Lisp, their list is linked list, okay, in Lisp. But what about Python, Ruby? It's interesting because, you have these annoying issues. One is that you can access any item fast, but you cannot add items. What the pain in the ass. Or you can add items to the front very fast, but then access any random element is very slow. So it's like a dilemma. So what does Python, Ruby, JavaScript do? Well, what they do is what they call, they create something called like a smart array. So basically, what they do is they just have a fixed array, a fixed length array. So that means you cannot add or remove element. However, when you want to add elements, the programming language is actually smart. So when you want to add element, it creates a new array, but with lots of empty spots. So later on, when you add elements, it doesn't have to recreate the whole. So that's why I call them smart array because there's no standard term, smart array. Basically, it's an array, but it automatically expand, create a new array with lots of empty spots, so you don't have to constantly recreate the array every time you want to add an item. So usually it doubles. Like if your array length is 10, then you add one more item, then it internally creates an array of 20 spots. So, and it keeps the index, it adds your item, but after that it's all 0, empty. But it's hidden from you. From your point of view, you are just seeing an array of 11 items, but beneath it, it manages these empty spots. So that's a smart array. That is done in Python, in Ruby, in JavaScript. Okay. Okay, so that is the explanation so far. What are we going to do? Why are we doing what we are doing today? We are going to try to implement a stack or a linked list in Python. And we are just going to keep adding push items to the front to see which is faster. Is the default implementation, Python list, is it fast, or our own implementation of linked list? Okay, let's see. So that is why we are coding today. Okay, so far previously it's just explanation. Okay, let's start to code Python. But let's write it down first. It's such that they internally create a new array with double the length when you want to add an item to the array, and hide that from you. Okay, something like that. Okay, now let's implement stacks in Python. Okay. Okay, so we are in Python. Okay, let's start to code Python. Okay, so we are going to use a tuple. So So what we are going to so an ordered sequence of things with two operations. Push is add an item in front. Pop is delete an item in front. Okay, that's what we're gonna do. So you have, first of all, you need to so you need to write a function. Let's I don't know if I can do it, but let's try it. Okay, can you have tuple of empty element? No. Well, yeah, but can you have tuple of two elements? Okay, can you have empty list? Okay, you can't even actually have an empty list. Okay, God. So to create a linked list, we need a pair, a data structure of pair. So, and in Python, the pair is done by tuple. Okay, so we want to create. Let's see, create. Okay, create linked list. Okay, and here X list. Okay, X list is whatever Python's list. Okay, and then we want to say we want to loop through it. Okay, so let's do loop through list. Dictionary loops through dictionary iterator to list, enumerate list. Okay, yeah, so we can do that. For item, for XX in X list, and what we want to do is, first of all, create a variable. Can we do that? Actually, I don't know. Okay, something like that. So you need the tuple here, something like that. Okay, can we run it? let's run it. Let's see, there's a syntax error. Finished. Okay, let's call it 1 2. Okay, run it. Trace. Okay, type error, create linked list takes 1 positional argument but 2 were given. Okay, yeah, okay, yeah, so you need a list. Okay, run it. Okay, it runs. So now let's print it. Run it. Fantastic. Fantastic. So we have implemented a linked list or stack. At least you know the how to create it. We need to implement push and pop. Okay, but now let's see type. Okay, now you want to see the type of, can you run that? No, invalid syntax. Okay, now type class tuple, exactly. Okay, now let's implement pop. The name is too long. Okay, let's just say linked list. Okay, so now we want to let's remove that. Okay, we want to define push and pop. Okay, push. Okay, now okay, add an item to the front of linked list LL. Okay, so add an item. So item. Okay, X. Okay, add X. Okay, so that's it. Okay, let's test it. X equals to, let's say x1 right? Fantastic. Run it. Fantastic. Now add x2, add push LL. Okay, push LL, you want x1 and push an item, let's say 3. Okay, we should have 3 1 2. Okay, now print x2. Error, LL is not defined. Oh yeah, this should be X. Run it. Fantastic! We have a linked list in Python, a stack. So anyone is watching, 4 people, say hi guys, say hi something, give me some, encouragement, give me some feedback. So we did linked list in Python. Fantastic. Now let's now what we need to implement pop. Okay, pop, delete the first item of linked list XLL. Okay, so pop just take one element. So So XXLL, you want to take the second item. Goksa, nice keyboard. Fantastic. Thank you. So pop linked list. So how do you get the second element of a tuple in Python? So let's see. Dictionary tuple. So how do you get the second element? Tuple iterable. I believe it's same as the same as list. Okay. Yeah. Yep. So return that second element. Python is indexed by 0, so the second element is 1. Okay, so run it. So far so good. Then let's say x3 equals to, let's copy that. Let's say x3 equals to pop x2. x3 equals to pop x2. Now print x3, run it. Fantastic. So we have implemented linked list in Python. That's all you do. That's all you need. This push and pop is similar to the Lisp's car and cadre. Okay, push in Lisp is called car. Weird name, historical, but if you call Lisp, And cadre in Lisp is pop, basically. Okay, so now we got a stack. We got a linked list, which is the standard implementation for stack, push and pop. So now we want to test how fast is this compared to normal, just use Python's normal list and delete the first element. How fast is it? So let's let's implement then. Let's try to implement using the normal. Okay, you don't need to create, because you can create you can just create a list in Python. It's built in. So but what if you want to push, let's say list. Okay, Python list, and the pop is also list. Okay, push Python list. We want to use a function here, because otherwise we have the cost of function call, because we are going to call push and pop for 1 million items, something like that. So, and we want to compare the speed of our implementation using of the stack versus Python's, So that's why we want to do a function wrapper. Otherwise, it's unfair comparison. So add x to the front of Python list XLL. Okay, so how do you add an item to Python's list? Let's see. Python list, count item, check existence, go to item, change item, delete item, get sublist, delete sublist, replace sublist. I think our stack is gonna be way faster than Python now that we are doing it. Join list. Okay, you can join list. You can do, but do they have? Let's see, list methods. Python is OOP, so you have. Okay, in Python, they don't have a prepend. They have append or extend. So the way of Python list implementation is that it's very efficient to add to the end, but not to the front. It just depends on your implementation. You can reverse it either way. So in Python, they do append. So let's use append because it's faster. We just have to remember the order are different, because we want to be fair to Python's list. So return. So what did we return? List append. Okay, copy that. So here is let's see, X list. Okay, So X list, then append X, okay? That's okay. Push Python list, okay? So that should be it. Add X to the front, to the end, okay? Then pop is the delete first item. So how do you do that in Python? Oh, there is pop. Wait, if there's pop, there must be a push too. What? Wait, let's try. You see a push? I think it might be append left, where append in Python will act as push. Okay, are you sure? But let's try if there is a push, okay? Let's run it. List object has no attribute push, okay? But what about pop? Okay, so Python has pop, but no push. Fucking idiotic Python. It has pop, but no push. Python is the worst language, okay? I really hate it. You know, I talked about this in lots of my videos. Search for it, you'll find it. So Python doesn't have pop. It has pop built in, but not push, okay? So we want to implement push. Let's just say append. Is there some shift, or I believe I have them all listed here. Yeah. Remove first occurrence, okay? That's not it. Okay, so first of all, let's focus. Push, how do you implement push? Okay, append. Okay, maybe there's append left, but it's slower, because I believe one day we tested with George, you know, George there. We test on Discord, and which end matters. So push is append, okay, and the pop. What about pop X list? Okay, so let's do pop. Pop delete the last item. Delete the last item of Python list X list. Okay, so delete the last item and return it. Okay, so you just do pop. Okay. Let's try. Okay, so let's now try it. Let's try our code. So okay, then let's say y. Okay, so print the type, and now push Python list. Okay, push y1, give it 3, then print. It should be 1, 2, 3. Then pop of y2, print y3. It should be 1, 2 again. Okay, run it. Okay, error. So pop ll. Okay, we got the variable naming incorrect. Pop. Okay, yeah, here. So you should say pop Python list. Okay. Okay, run it. X list pop. What? None type object has no attribute pop. So here. So X list. What? So there is pop, but why is it not working? Stack, line 39 there. X list pop. So X list, so this is pop Python list. So Y2 is a list, and you want to pop it. Why can't you pop it? Return xlist.pop, attribute error, none type object has no attribute pop. What are they talking about? Anyone knows? It doesn't return. Oh, what? Remove the last item and return that item. It doesn't return. What? Where's the... that's the error message. It's return Y2 is none. Oh, right. Thank you. So let's see. Y2. Oh, yeah, right. Y2 is none. So should we return or not? Let's check. So in our function, we do return it. So when you push, normally when you push, you want to return. Yeah, normally, yeah, that's the case in Lisp, in linked list. So when you push, you want to return the new list, okay? So therefore, we need to have it returned. So append, then return this, okay? Thank you. Secondary account, thank you. Fantastic, okay? Fantastic. Now let's try it also to print Y2. Now let's double check one last time, because next step we are going to time it. We are going to push 1,000,000 items, something like that. So double check they are actually doing the same thing. So we have linked list, linked tuple. So yeah, we add 1, 2, 3. We add an item. Then we drop an item. Okay. Now in the Python list, you have a list 1, 2. Order is the other way. Then 1, 2, 3. Then you so we need to actually return the item here, not just return the new thing. So we need to modify here x2 here, push just return the list, and pop needs to return that item, but it also needs to pop needs to return that item also modify the variable. So okay, so this is what we need to do. So XLL equals to XSLL equals to the second part, but you first something like that. So you get the first item of this nested tuple. You get the first item, then you set that XSL to the rest item, then you return first. Okay, yeah, that's what we want. Let's do it again. Let's run it, double check one more time. Let's run it, double check. Okay, check. What are we doing? Create, push, and pop. Okay, create, push 3. Okay, then pop. Okay, then pop. Okay, so pop. Then when we pop, oh yeah, this should be 0. Okay, 0. Do it again. Create, push, pop. Okay, then we need to print x2. Okay, create, push, pop, print x2. So x2 is not, it didn't change. When we pop x2, wait, maybe it's better if we create, then push x1, push, when you push x2, okay, print x1, x2. So x1 and x2 should be the same. Okay, let's forget about pop and let's forget about the others. So just to verify, so they are not the same, but false. Okay, hold on a second. Okay, run it again. Create comments. Okay, comments. Push, print x1. Yeah, we need to, x1 is, yeah, pain in the ass. x2 is, okay, x1 is that, x2 is that, they are not the same. What? x2, oh yeah, obviously they are not the same. Fuck, I made a mistake. Shit. No, okay, so obviously they are not the same. So we don't need the type. Try it again. x1 is x2, x2 is that, obviously they are not the same. Then when you pop x2, when you pop x2, so x2 changed. Hold on a second. And let's say pop 1. There's no x3, so so you print the pop value, then you print x1 and x2. Okay, do it. So when you pop x2, the pop value is 3, so it didn't set. x2 remains the same. You see, x2 should be one value removed, but it remains the same. So the pop okay, yeah, so you know, I know what's the problem, because you see, this XLL is local. It does not, shit, this is more difficult than imagined. This XLL is local to the function. So you need to kind of, how do you, wait, Python is passed by reference, right? So XLL so if you just popped value is correct, okay, but however it doesn't change this. It doesn't actually delete the element. So we have to think about, so x2 is a tuple, nested tuple. Okay, so when you call pop LL, it's defined, it takes a tuple. And does anyone know how to solve this? It takes a tuple. Oh yeah, so here you are creating, this is a complex issue of Python. So here you are creating, can you actually use pop? I believe you can. So list methods, so can you actually use pop? Okay, let's do a alternative implementation. So pop, it's a tuple, so you just pop the tuple. That's right. So you pop the tuple, XXL, pop that. Okay, now let's see. Tuple object has no attribute pop. Fuck Python. when you have a tuple, you want the same tuple. You want the, because it has to do with the references. Tuple methods. So what are the tuple methods? Does anyone, do we have a Python coders here? Look through tuple. Convert iterable to tuple. Tuple cannot change. Oh yeah, that's why tuple cannot change. But yeah, but how do you implement it? I mean, how do you implement linked list with tuple? Fuck. Maybe we shouldn't use tuple then. Let's use Python's smart array to implement. Yeah, let's do that. So what we're gonna do is we pop this out. So here's today's talk show. So here's our Python code. We're just gonna make a copy of it and do a second implementation. So syntax correct, and let's do a second implementation. This time we use Python's list to implement the pairs. Okay, so not tuple. Okay, so I think that's that. Then push is, now since we are using Python's list, yeah, we still push to the front. Okay, so yeah, so if you do, let me show you. So if you do this, that's not good, because this creates a new list. You see, it's a tricky problem because you want to modify that. You don't want to create new. So here you have, oh, I think secondary got a solution. No. Let's keep going here. So if you push, you don't want to return a new entity. You want to just modify that entity. Oh my god, this is problematic, because then you're gonna have recursive lists. Yeah, god, this is close to 2 hours now. So so the problem right now is to implement push and pop. The problem now is that when you give a list, you want to return the same list. You don't want to change it, because that's what push and pop do. It modifies the list. But if you say, if you do return this, that that actually return a new different list. So therefore, to fix this one, for example, you want to let's go back to list methods. Generate list comprehension. list methods. Oh God. So okay, so let's use append then. If you use append, that means you also add to the right. Okay, let's use append, because that way you don't return a new list. Okay, a lot of complexities and frustration. So okay. Wait, that's not. Wait, you can't do that, because the point is you need to nest them. The point is that you need to nest them. So, oh God, so there's a lot of operations you have to do. So given a list, you need to remove so the argument here is a nested list, Python list. Each element has just 2 items. So when you push, yeah, this is hard to do. You because you need to, you can't just create a new one. You need to, when you push, you need to put the first item to the second item, and the new first item is the argument. Yeah, something like that. Okay, so let's try to do that. So when you push, you want to something like this, okay? Something like this. So this is new item. Let's say x new, okay? So this is new item. And you can't just return that, because that just create a new thing. So you need to so this is something like this, okay? So you have the first and rest, and then you want to say you want that to be the x new, okay? And you want the rest to be that's right. So this way you just modify the tuple. You don't actually create a new entity. So yeah, so this way you modify the tuple. Let's see, maybe that'll work. But you do this, there's a cost of the assignment. That should be fast because it's just references. Yeah, so okay, does this work? Push LL, okay. tuple object does not support item assignment. Now, tuple, okay. What? Okay, so it's not a tuple then. Yeah, so this should be that. Okay, run it. Okay, we are getting close. Create 1, 2. Let's say create 1, 2, 3. Okay, x1. Then push that doesn't work. Okay, yeah, some mistake. X1 is 4, yeah, so there's some error. XLL is a list of 2 items. Okay, so first rest. Okay, and let's run it again. What? Yeah, so that. So XLL new is oh yeah, so this should be XLL. Oh wait, and then you get recursive thing. Yeah, you get recursive thing. Yeah, God, this is hard to implement. We got a recursive list. But I'm not sure I can do it. You know, so the problem is pretty simple. Implement, list, linked list in Python, and right now we just failed at push. So okay, well, but the solution is to look at Python, where how you can maintain the reference. Yeah, but the thing is, if you do that, then even essentially you are going to recreate the list. That defeats the whole purpose of linked list. You cannot, every time you create a new item, push your item. You do not want to recreate the whole list. So, and yet the problem is, yet you want to maintain the reference. That argument must not have a new reference. First rest. So we don't actually need the rest. The second element is Yeah, so that's a problem. So here, what you can do is like copy, something like that. Do we have an example here? But you cannot use copy, because you do, then that's just creating a whole list, which is super inefficient. So do we have any Python experts? Dictionary, tuple sets, sequence types. Sequence types. Sequence types, dictionary methods. So copy nested list. So I do have a, yeah, so this is how you actually make a copy. So what you do here is you just say list that, but that defeats the purpose, although that, because this is making a copy of list. Oh wait, it's the shallow copy. Shallow copy is no good because it's using references. Then you get recursive, like we did. We got a recursive list, basically infinite. So this part is referring to 321, and something like that. Juicy boy. So, Juicy boy, do you see what I'm doing? Do you understand? Do you have a solution? So actually we got stuck. We got stuck in implementing a linked list in Python. While trying to maintain the properties of linked list efficiency. And not just linked list, we need to create push and pop, which means it needs to, given an argument, it needs to modify the argument. And meanwhile, not recreate, the copy of your list. It should nest. So we are stuck here. And as far as I know, at this moment, I'm not even sure it can be done. Okay, I'm not sure it even can be done. So we essentially failed in Python so far. I would conclude I'm 80% confident it cannot be done. 80% confident. You cannot create a efficient stack structure in Python without getting into C. So you can write a library using C. For example, let's look. Maybe there probably already is. You have to code C module. Create a Python module in C something. So Python stack. There it is. Okay, there's a Stack Overflow question. How to implement a Python stack? You see, people actually ask those questions. Okay, let's check. Many of these are low quality shit blogs. They write that because they want money, ads. So let's look at some of them. Okay, Stack Overflow usually is trustworthy. Push pop. Okay, first implementation. The following stack implementation assumes at the end of list will hold the top elements of the stack. Okay. Idiotic. It's not a stack. It's just push and pop using the default Python list. So let's see. it's just a wrapper, you know. It just reverse order, that's all. So you push, it just call append. So there's no change, no actual change. You know, it's just Python list. It's not really a stack. The second implementation assumes that the beginning of the list holds the top, okay? Yeah, it's just a wrapper, so it's no good. You see? So it says lists are optimized for appending and popping from the end. Inserting or removing an item from beginning of a list is much more expensive because Python does have a data structure collections D key. Okay, that's not what we, you know, they are just talking about which side is more efficient to add. It doesn't actually touch on the nesting data structure. So I doubt you will find the answer online. So what's how, you know, these are the most idiotic usually with you know, pretty picture. This scum website. What's a stack? Okay, blah 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 blah. Implementing a Python stack. So you just use the key and list of key. Now I wonder, so the library the key or key, are they using, wait, key is not a stack actually, so key is no good. You know, they are just using lists. They are not yeah, you see append, pop, whatever. Using lists to create a Python stack, okay? Using collections.dkey to create a Python stack. Okay, so the collections module contains the key, which is useful for creating Python stacks. The key is pronounced deck, okay, deck, and standard for double-ended key. Oh, it's fucking idiotic. So stack, okay, again, so the real answer lies in the D key. How do they implement this? Is it just a wrapper or is it actual C code? Where is it? Returns a new D key object initialize. D key are generalization of stacks and keys, okay? The key supports thread safe, memory efficient append and pop. There it is, okay? This is what we want. This is what we are trying to do. So right now, what we have to do is to look at the source code of the key, okay, to see whether it's actually Python code. I doubt. I think it's C code. Okay, because so far from from my experience, I don't think it can be done. So yeah, so we have to look at the collections D key source code. Okay, let's search for that. So library locations source code. Okay, where's my? Okay, let's put some comment here. There is, okay, let's see if there's collections D key. Let's see if its source code is in Python or C. Okay, search for that. We need Python. Okay, there, Python documentation. We need the Python source code. Can we actually, so where is Python library? let's just go look at the Python library. So Python, you need to print version module. You need to print Python's library location. Okay. Oh yeah, so I think, okay, let's go look. Okay, Python. What's the difference? Okay, those are binaries. There it is, collections. Okay, what the heck? Yeah, so you see, it's C code. What is this ABC? Collection ABC import, or wait, is that? There it is, the key. This module implements specialized container data types, providing alternatives to Python's general-purpose built-in containers, dictionary, list, set, tuple. Exactly. So the key. So there it is. So and so init. So these are init. Let's see. Search for that. Copy. List all lines containing it from collections import. Okay, let's go to it, go to it. Okay, so you don't get the source code because the source code is in C. These matching lines, DEF. Pop item, named tuple, most common. Okay. From key, copy. Okay. So there's cache. So why is it named abc.py? Does anyone know? Why is this abc.py? There it is. That's the cache, but can anyone confirm this is C code or not? So right now we want to determine the source code of Python collections.dkey, whether that's C or not. There it is, source code. Wait, no, this solutions problems of hacker rank of Python module. What the? No. So let's go to Python source code. Python GitHub. C Python, I suppose. Modules lib. Collections. Turn on JavaScript. Add callable generic alias collections ABC import or init py. This is what we have seen. But where is the does anyone know Python coders out there? Nobody. Okay, so nobody, I guess. Where is the how is Python's library organized? I mean, how is it? Let's see. Let's go up. Here is what is this? Okay, I don't know what are those files. DLLs. There it is. So there's a key. Yeah, so I don't know how Python's source code is arranged. Collection not there. So we need to know okay, so in this case you need to read up the Python implementation detail, which I've never read before. So extending and embedding, something like that, something there. So library reference, magnify, collection packages, container data type, abstract base classes for containers. Oh, that's what ABC stand for. Abstract base class. Okay, so key, the key is implemented as the abstract data class. Okay, so but I want to know if the key is written in C. 99% sure, but I want to be 100% sure. Okay, so that's what we are doing. So collections, okay, container data types, okay, abstract base class, container data types. Okay, so you have the key. This module implements specialized container data types, okay, alternatives to Python's general purpose built-in containers. Okay, so let's see the key. The key, this is a class, so it's an object. So the key is supposed to be a generalized stack, meaning that it can be a key or it can be a stack. A key is first in, last out, something like that. It's it's like a line, waiting in a line. So the key, so you have the key, but does it mention how is it implemented? Changing version 3.5, new methods, okay, blah blah blah, software last updated. So okay, so this is alternative data structure. Okay, and but where is the C code? That's what I want to know. Is it written in C? Source code. Oh, here, source code. Wait, is it? It is written in Python. So source code is just the init.py, okay? Source code is just init.py, okay? Connections. This is a source code. Okay, so you can use self. That's right. But if you do that, only if it's shit. Okay, so okay, now it's getting closer. So it's not written in C. It's not written in C. So let's go back to the documentation and let's read about these class collections. List like container with fast appends or pops on either end. Okay, so let's look at that. Key object, okay. O1 performance in either direction, okay. Though list objects support similar operations, they are optimized for fast fixed length operations and incur OM memory movement costs to pop and insert. Exactly. Operations which change both size and position of the underlying data structure. Okay, that is what we've been talking about. Okay, so if max length is not given, is not specified or none, key may grow to an arbitrary length, otherwise key is bounded. So this key is like stack but open in both ends. So how do they implement that? I suppose it's doubly linked list. Okay, so but we are getting closer. We are getting closer to look at how they implement that. So here is an example of how to use it. So you import it, then you just say key. What? A key is a string. Iterate over the keys elements. GHI. What? The key deck, that's a string. So you have pop, return and remove rightmost item. Then you have pop left. Then you have this bothers me. So the input is a string. What? Okay, let's search for pop. What about the abstract data class, abstract basic class? Doesn't say much. So this file is 1500 lines. 1500 lines. And I suppose we can read, you know, well, if we have time, we can read the entire thing. 1500 lines, which is not too big. So the key, try import the key, import error. So try from underscore collections. Okay, So try from underscore collections. Yeah, it's in C. I'm pretty sure. So what the fuck is underscore collections? You see? So underscore collections there. What is this? Oh, what the fuck? So how many lines is this? 1000 lines, not too much. Let's search for key. Search for the key, okay. Underscore collections, abstract base classes for collections according to PEP 3119. Fuck the Python PEP. Introduction, introducing abstract base classes. Fuck Python. 2007, Guido van Rossum, idiot. Rationale, acknowledgement, rationale, specification. Anyone here? Python experts. We need Python experts. Okay, if you are, say it. So, and right now we are trying to find out this dkey library, this dkey module, is it written in Python or in C? Let's search DEQUE, okay? And I tried to implement it today in the past hour and failed because of the reference issue. I cannot do it without screwing up the properties of proper key data structure. And so actually that's very interesting, in fact, because I thought it's just possible. It may not actually be possible. I mean, from a functional point of view, I mean, what it do, yeah, of course, you can just create a nested tuple, tail nested tuple, but then you don't have the efficiency property. That's a problem. Especially because of the operations push and pop. They need to modify the variable. You know, the variable whose value is a least ordered sequence. You cannot return a new one. So, but in order to do that, the language needs to be able to use references. You know, reference to that object. No, you still need to modify the object. So you need to somehow work in a lower level. So right now I don't think it's possible to implement an efficient stack in Python with Python language unless you go into C code. And that's what we are trying to determine now. So search dkey. Dkey is not found here. So what is the underscore thing? So let's see. Abstract base class collections according to PEP. Okay. Unit test. Okay. Unit tests are in test collections. Okay. Abstract means okay. So here, you see, right now, what is the difference between collections and underscore collections? You see, so there is that. So it's trying to from underscore collections, import the key, then multi-sequence register decree, mutable sequence. So if that fails, as underscore collections dot mutable sequence. Okay, so the key is in these low line collections ABC. But here, that's 1,000 lines. But I'm not seeing any decay here. Okay, decay all. So this is all exported symbols. Mutable set. Okay, that is that. Okay, mutable sequence. Okay, now let's go back. Lib collections abc.py abstract basic class, basically import all. Okay, and it's from, okay, again it's import from underscore collections underscore abc, and this init shows that all the symbols it exports. So search for the key, yeah, there. But then you can see it's try to import from underscore collections. So that's these matching lines, that's all the occurrence there is. So okay, so the main one is just this one, must be underscore collections abc.mutable sequence.register d key. Okay, underscore collections underscore abc mutable sequence dot register. Yeah, so mutable sequence dot register. Okay, now let's go to the underscore. So there is mutable sequence. Okay, so there, so you are importing this, yeah, so you are mutable sequence, wait, mutable sequence dot register. So there it is, there is pop. There it is, mutable dot sequence dot register. Okay, I failed to determine whether it's in C code or not. It will be another day. So now it's 2 hours and 30 minutes. Thank you guys for watching. 0 people watching now. Oh, 3. So today the first hour we explained, you know, where let's summarize. In 3 minutes we shut down. Okay. So first hour we summarized the problem we are trying to do, which is where is it? Okay, you know, the jargons, you know, the concept ordered sequence of things, and what's the difference between array, list, vector, tuple? Why are there these things? The reason they are there, and the meaning of them, the algorithmic properties, and why do you have those differences? So why do you have, you know, list, array, key? Why are they different? Why is that sometimes, you know, their algorithmic properties are different? The reason, what's the cause? Then we explain what's a stack. Then we explain the list, how it's implemented, which is a linked list, you know, the jargon. Then the critical concept of array, the most common concept in C, which is a fixed length, but random access, constant random access time for any element. And from that, and then we explain why is it constant access time. This is the most important. Why is a C array or Java? What the concept fixed, you know, array? Why is it constant access time? And because of that, that's because the machine implementation, the physical machine, because the parallel circuit, basically the nature of the parallel circuit in memory chips. So that's why array access is constant time. Then so from that is basically all programming language is based on. So you have constant time array access. Then you have linked list. Then you have smart array, which is done in Python, Ruby, JavaScript. Then okay, so then we are trying to implement linked list in Python. In particular, we are trying to use it as a stack. So we are trying to create a data structure in Python with push and pop operation such that they are efficient. They are very efficient using linked list. But so that's the second hour. The second hour and the third hour, we were trying to do that. And we failed. We failed because we can't make it actually do what they do. So then I tried to search the third hour. I tried to search whether apparently there is a library called these collections that implements what we wanted. They call it DEC or DKey. DEC, I suppose. Let's see Wikipedia. Is that oh yeah, so okay, there it is. Double-ended key. Okay, so a key is like a key is just like a line. You waiting a line. So the first person come in the line, the first person to go. And double-ended key just means you can move in both ways. So once you have that, then it's kind of generalized stack. Okay. So anyway, so Python has this library, but I failed to determine whether that library is written in C or not. Because if it's written in C, then it showed that it's true that we cannot implement it in Python code. We have to dive into C because the Python language does not expose sufficient thing. So I'm not able to determine whether that's written in C or not. But meanwhile, it does appear it's not written in C. So if it's not written in C, so that means it's possible to implement this efficient stack or DEC in Python code. So the question is how to do that. So we spent 1 hour trying to implement that, and the difficulty is that you need to somehow manipulate the reference, and I wasn't able to do so. So I don't know. Maybe I'll So that's it for today. Bye guys. I'll ask some Python expert. Dion is a Python expert. Bye guys.